Okay, so up to this point in time, we have talked about work, we have talked about power, and now I'd like to introduce a concept called energy. Now, energy, as you guys may know it, may be what you refer to as you don't have enough energy to pick something up, or to go to school in the morning, or to do, any sort of, I guess, what you would call work. Um, Also, you may think of work as maybe just like light. It takes energy. You need to plug something in so you can get enough energy so that you can power a light bulb. And so that is a form of energy as well. Well, in terms of physics, by definition, physics is our energy is the property of matter that gives it the ability to do work. Now, whenever you want to get some work kind of done, it takes some sort of energy. And so you expend energy, and generally work gets done. So that is by definition what energy is in terms of physics. And in terms of types of energy, you may know of like thermal energy, or you might get nuclear energy, even electrical energy. And what we're going to focus on is something called mechanical energy. Now, there are two types of mechanical energy, though. There are potential energy and kinetic energy. And you may have heard these terms in previous science classes, but now we're going to get a chance to actually do some mathematical computations with it and to get a better sense of what each of them are. So, to begin, let's take a look at potential energy. Now, potential energy, I want you to know that the symbol for that is going to be PE. And PE, of course, means potential energy. And the specifics about potential energy are that it is the energy possessed by an object by virtue of its position. In fact, depending on its position, it has the potential to do work. And so what that might mean is, take this instance here. We have two people, I guess person A and person B, and both of them have a 1 kilogram ball above their head. Except for person A, he has it 1 meter above his head, and for person 2, B, he has the ball 3 meters above his head. And if I were to ask you which one has the potential to hurt the gentleman more, I'm sure you would refer to as person B versus person A, because you know that because it's higher, it has the potential to do more pain. Or in this case, it actually physics with more potential to do more work on that guy than in this one on this guy. So if we actually look at the formula for potential energy, we'll see that you are in fact correct. And so to begin, the formula for potential energy is PE equals mass times gravity times height. And so by doing the math here with our 1 kilogram object in both situations for heights, we can see that one definitely has more potential energy than the other. In this case here, we have the 1 kilogram object, gravity, which is 9.8 meters per second, and the height, which is this in case 1 meter above his head. We have 9.8 joules of energy that is potentially going to be done on him. Now, in case of this gentleman over here, we have the 1 kilogram object, 9.8 being gravity, and 3 meters above him. So there's actually 29.4 joules of energy or work that can be done on this guy. Clearly, with this ball being higher, it would have more potential energy. I'm going to use this pen here to actually do a different example here. What if I were to have another ball? And this ball were to have, let's maintain it as the 1 kilogram ball. But I want to move it a little bit higher. In fact, in this situation here, I'm not going to have this 1 meter here, but I'm going to have 2 meters. Okay, so I now have still the 1 kilogram ball. I'll go ahead and make this guy black so it makes it easier for you to see. And it's 2 meters ahead. Now on this case here, I'm going to actually lower this one. I'm going to lower this one down to about right here. However, the mass of this ball is going to be greater. Let's consider it to be, I don't know, 3 kilograms. And the height for this guy is going to be 1 meter above. his head. If we want to find out which one of these two cases has more potential energy, let's go ahead and do the math. So mass, in this case, over here is going to be 1 kilogram times 9.8 times the 2 meters. So we multiply through and we're going to get 19.6 joules of energy. So the potential for this 1 kilogram ball 2 meters above his head is 19.6 joules. However, this ball is a little bit heavier. However, it is lower in terms of, I guess, closer to the guy's head. And if we were to do that math, we have the 3 kilograms, which is your mass, 9.8 being the gravity, and the height in this case is going to be 1. Now if we look at this, they're very close and similar. It actually comes out to be 29.4 joules, just like this one is. But what's kind of interesting here is that even though this ball is lower or closer to the head, because of its mass, it is still indeed has more potential energy than this one does. So that, in a sense, is how potential energy works. However, we cannot forget that there's actually another form of energy. It's called kinetic energy. Now, kinetic energy, instead of having energy possessed by its position, it is actually the energy possessed by just a moving object. And so when an object moves or is actually moving, based on its mass and its velocity, it's going to actually have some sort of energy. So I have two situations here. I've got two vehicles, each equal in mass. However, both of them are going at different velocities. Vehicle A is going at 5 meters per second. Vehicle B is going at 20 meters per second. Of course, for vehicle A, we have 1/2 times 100 times 5 squared. For vehicle B, we have 1/2 times 100 times 20 squared. If we were to follow our work through, we would find out that vehicle B has a considerable amount of energy to it. In fact, it's all kinetic energy. And based on even though the velocity is only 4 times greater, you can see that the kinetic energy is far greater. In fact, it's, more than 12, 16 times, stronger. Actually, not 16 times, but quite a bit. And so, with that being said, we want to make sure that we understand that the squaring of this has a considerable amount of, of power to really multiply the amount of kinetic energy that is actually in the two different cases here, and not necessarily just the multiple or the difference between these two here. I hope this is helpful, and stay tuned as we discuss how kinetic and potential energy are related, and also how work is related to energy. Have a good day.